Hello everyone. This is the fifth episode for the acid, bases and salt for class 10. Student, we have already done acid and bases. We have done the physical and the chemical characteristics of the acids and bases. We have learned about the preparation of acids and bases. Today, we are going to know about salt. So before knowing salt, you should know the definition of a salt. So student, get ready for writing the definition for salt. We state salt is a compound, please write down, salt is a compound formed by the partial or complete replacement of the ionizable hydrogen atom. By the partial or complete replacement of the ionizable hydrogen atom of an acid by a metal or ammonium ion. I will tell you once more. Please write down, salt is a compound formed by the partial or complete replacement of ionizable hydrogen atom. Please be aware of writing ionizable because not all hydrogen should be replaced by the metal or ammonia, but it should be replaced in only the ionizable hydrogen atom. So ionizable hydrogen atom of an acid by a metallic ion or ammonium ion. So let us see how the salt is formed. I can state about an acid, hydrochloric acid. I can state about an acid called sulfuric acid. I can also state an acid which we call it as carbonic acid. Now, this is the ionizable part. This is the ionizable part. This is the ionizable part. And this is the ionizable part. If I take HNO3, then hydrogen is the ionizable part. This is the hydrogen which is ionizable part. If I can replace it with a metal, just take any metal to your choice. I can take sodium. So if I replace the hydrogen with sodium, it is a salt. If I replace the hydrogen with ammonium, NH4Cl, then it becomes a salt. If I remove it with calcium, 2 hydrogen atom is replaced by 1 calcium, then it forms a salt. If I take zinc and add here the carbonate part, it becomes a salt. So what you have learned, it is the complete replacement, and now I will be giving you some example of the partial replacement of the hydrogen atom. Like I say here Na2SO4, and I will give you one more example, NaHSO4. This is sodium sulfate, sodium bisulfate. How it is formed? Now let me take H2SO4. Here in this case I have two options. One is complete replacement of hydrogen atom. So if I can completely replace it, it becomes a salt which we call it as a normal salt. And here if only one hydrogen is replaced, check it student, if only one hydrogen is replaced, still it becomes a salt. This we call it as an acid salt. Now student, here you have understood sulfuric acid, I am replacing both the hydrogen or I am replacing only partially a hydrogen. If it is a partial replacement, it is called as an acid salt. And if it is a complete replacement, it is called as a normal salt. In this way, we can define a salt as salt being a compound which is formed by the partial or complete replacement of the ionizable hydrogen atom by a metal or ammonium ion. Now let me give you an instance. Taking example for CH3COOH. So student, you can see there are many such kind of hydrogen. Which hydrogen is replaceable or ionizable? It is only this hydrogen which is replaceable or ionizable. So here it will be CH3COONA, and it cannot be CNA whole 3 COOH. It is not the way. So only the hydrogen which is ionizable would be replaced by a metal or ammonium ion. So if I take ammonium ion, it would be CH3 COONH4. This is what we call as ammonium acetate. This is called sodium acetate, and the other way it is not possible. So student, here we have defined the salt. Now let us see about the types of salt. So next phase we will be seeing about the types of salt. So now we are going to go with the types of salts. So there are as many as 6 different types of salt. First let us see, I have already discussed normal salt and the acid salt. So student, keep on remembering, number 1 is the normal salt. Second, the acid salt. The third, we have the basic salt. The fourth, we have the mixed salt. The fifth, we have the complex salt. And finally, we have the double salt. So now, let us see all these 6 different types of salts and try to understand each and every salt vividly. Here we go. So student, we have the types of salt. This is the types of salt. We have to understand with some suitable examples. Like, I have taken normal salts as point number 1. Here you can take it as NaCl. You can take it as Na2SO4. You can take it as NaNO3 and so on. You can see here there is a complete replacement of the hydrogen atom. Here you can see it's a complete replacement of hydrogen atom. There is no such hydrogen atom which is ionizable. Now in the acid salt, this is the second category of salts, this is the acid salt. In acid salt you have yet an ionizable hydrogen atom. So all the hydrogen atom which is ionizable is not completely replaced by a metal or ammonium ion. I have to give you some examples stating as like NaHCO3, sodium bicarbonate, sodium bisulfate, sodium bisulfite and so on. So you can see here it is an incomplete replacement of the hydrogen atom. If I take example like H2CO3 and add sodium to it, if I add sodium to it, what happens is that it is going to react to produce NaHCO3. It is going to react NaHCO3, and if I take here NaCl, it is going to form ACl. So there is no complete replacement of the hydrogen. There is a partial replacement of hydrogen. So this type of salt is formed by the incomplete replacement of the hydrogen atom. So here you see the acid salt. How can you understand the acid salt? The presence of the ionizable hydrogen atom. Another important thing that I should tell you here, that this type of salt, on addition to water, when we add water to it, it is going to produce hydronium ion also. Like if I take sodium bicarbonate and add to water, it is going to produce Na plus, it is going to produce H3O plus, it is also going to produce CO32 minus. So the presence of H3O plus indicate the presence of the acid salt. So on all acid salts, if you add water, you are going to get hydronium ions. It is confirmed. So in this way, you can identify acid salts, and acid salt due to the presence of the hydronium ion in the water, the solution would give a change in color of the blue litmus to red. Our next salt is with the basic salt. So in this basic salt, you can understand here the presence of hydrogen produce acid salt. For basic salt, there should be the presence of the OH group. And it is possible that all bivalent metal atoms, they can undergo forming the basic salt, as we have seen in the acid salts also. Like if I take calcium, calcium has got 2 hands. Here one hand it has the OH, the other hand the Cl. If I take magnesium in one hand it has a OH, the other hand it has a Cl. So this is basic magnesium chloride. If I take copper has got two hands. If one hand is replaced with OH, the other hand is replaced by Cl. This is what we call it as basic copper chloride. If I use it as sulfate, basic copper sulfate. How you write it? CuOHSO4. So this is basic copper sulfate. In this way, we discriminate the acid salt, normal salt from the basic salt. So basic salt has the presence of the OH group. It's a must. So all basic salt has the OH group attached to the metal atom. Fourth to go is about the double salt. These are two salts which are being added together. Let us see. I have examples with K2SO4. This is called potassium sulfate. I have together with it aluminium sulfate. So this is aluminium sulfate. So aluminium sulfate together with the water molecules, they form double salt. How can we understand the presence of the double salt? You just add this type of salt in water. When you add in water, they will have the ions of potassium, sulfate and aluminium. So all the constituent element forms ion. All the constituent will form ions. This is how we discriminate from the others. So you can see in case of the double salt, this is one salt, there is another salt, they are attached together with the water of crystallization. If I take, this is what we call as the potash alarm. Now when we go for making the more salt, so student, in making the more salt, we have taken ferrous sulfate, we have taken ammonium sulfate, Na4 twice SO4. So in this kind of ferrous sulfate with ammonium sulfate, we can add it with the water of crystallization, 6 molecules of water, it forms a double salt. So this is the example for the double salt. The double salt would have two salts together being attached together with water molecule. So potassium sulfate with aluminium sulfate, two salts being added together with the water of crystallization, ferrous sulfate with ammonium sulfate with 6 molecules of water. This is what we call it as potash alum, and this is what we call it as more salt, MOHR, more salt. So these type of salts are called as double salt. So get it clear once more. So student, let us go to the fifth type of the salt, that is mixed salt. In mixed salt, we will see either the salt contains acid radical more than the basic radical or basic radical more than the acid radical. To cite some examples, I would just say about CaOCl2. So in this case, you can see that calcium is having two hands. I will just rub it out. So calcium has two hands with oxychloride and chloride. So you can see, student, they are the two acid radical and one basic radical. So if it happens that a salt contain, in all other cases you can see one acid radical, one basic radical, one acid radical, basic radical, one acid radical. So in this case you can see a metal having two radicals in comparison to one. In this case, we can also have NaKCO3. Here two metal atoms, one the non-metallic radical. So here you see this is Na plus, K plus, CO3, 2 minus. So what is the importance of this type of salt is that whenever you take this salt, you have either two basic radical, one acid radical, or two acid radical, one basic radical. And finally we have the complex salt, that is the sixth type of salt called as the complex salt. I will just give you an example. With this example, it will be convenient for you to understand the difference between the mixed salt and the complex salt. If I take K4FeCN6, FeCN6. So if I take a salt called K4FeCN6, this is a complex salt. Why I will say complex? Because when I will add in water, when I will add the salt in water, it is going to break up into 4K plus FeCN6, the whole 4 minus. You can have the counter ions here, but the total, the coordination entity remains intact. It does not break up into the constituent ion. It does not break up into constituent ion. So if it does not break up into constituent ion, we call this as a complex. But the other case, when I have stated here NaKCO3, in this case, when I will add in the water, they will break up into Na plus K plus CO3 2 minus. So in this way, we differentiate between the mixed salt. So this is a mixed salt and this is a complex salt. In complex salt, the coordination entity which is within the parenthesis, within the third bracket, is called as a coordination entity, and the coordination entity will not break up into constant ions when they are added to the water. But whatever is present outside the third bracket would be ionizing, but within the third bracket it won't be ionizing. So let us go with the properties, or better I say, the physical properties of salt. First thing you should keep in mind that all the salts we know is an electrovalent compound. Better we can call it as ionic compound as well. And this ionic compound has a certain characteristics. Yes, student, you have already learned in your lower class that ionic compounds, it breaks up into ions when they are added to water, or in their molten state. So salt, when you are heating it, making it liquefied, or when you are adding to the water from an aqueous solution, it breaks up into ions, and the ions are the carriers of electricity. Now let us make a small summary out of this point. What is that? Ionic compound, salt, an ionic compound, it breaks up into ions only in the fused state, that means molten state, as well as when they are added to the water, that means the aqueous state. So salt, the first thing is that physical properties of salt. In the physical properties of salt, the first thing is that salts are ionic, IONIC. They are ionic compound. So being ionic compound, number two, they are hard. They are usually hard crystals, crystals. They are usually hard crystals. Number three, they are usually soluble, SOLUBL, soluble in water. Usually, there are some salts which are not soluble in water even. That we are going to discuss later. But being an ionic compound, these are usually the characteristics. They are usually hard crystals. They are usually soluble in water. Number four, they break up into ions when in molten state, MOLTEN, molten state, STATE, molten state, or in aqueous, AQEOUS, aqueous solution. So in aqueous solution or in the molten state, they break up into ions like NaBr. When you heat it, they will break up into Na plus and Br minus. And if you are taking NaBr, so or say NaCl in the aqueous state, in water, it will break up into Na plus and Cl minus. So you can have the ions only when you are adding to water or when you are heating it. You are melting it out. And when they have the ions, they conduct in the ions then can conduct electricity. Now if we ask the students under what circumstances the salt can conduct electricity, in the solid state they won't. So only in the molten state or in the aqueous solution they break up into ions, and once the ions are being formed in the molten state or in the aqueous solution, they would be conducting out the electricity. So students, this very point about their solubility in water, we are going to discuss a lot about it. So very quick, we are going to discuss about how the salts differ in their solubilities in water.